Namaste student. I am JVN Dr. Sudhir Kumar Srivastava from the Department of Science under the Faculty of Education and Methodology, JAYOTI VIDYAPEETH and Institute. By the last lecture, we are introduced by the theory of group, by the definition of group, and what is the meaning of the abelian group. Now, we will share some slides about the group, that is group. An algebraic structure G, O, where G is non-empty set with operation O defined on G, then the structure G, O is said to be a group if it satisfies the following properties. First property is the closure property. The set G is closed under operation O, that is A operation B belongs to G for all values A, B belongs to G. Now the second property, associative law. The set G is associative under the operation O, that is A operation B operation C is equal to A operation B operation C. For all values A, B, C belongs to G. Now the next property, this is identity law. There is an element E in G such that E operation A is equal to A operation E is equal to A for all values A belongs to G. Now the next property, existence of inverse. For each A belongs to G, there exists an element A inverse for every operation in G such that A operation A inverse is equal to E is equal to A inverse operation A. For the example, R comma plus and Q comma plus. This was the review of the last video lecture. Now today's topic. Today's topic is the properties of the abelian group. Sorry, the properties of the group. In the properties of the group, there are some properties described as the element must belongs in G, identity element must belongs to G, and identity element of the unique for the particular operation will be unique, and inverse is also unique for all and each elements of belongs to G. And A operation B to the whole inverse is equal to B inverse operation A. This is called the reversible law. And same the cancellation law, A operation B is equal to C operation B, that implies A is equal to C. Now again I will share some slides to better understand of the properties of the group. Now see, first cancellation law. If A, B, C belongs to G, then first A operation B is equal to A operation C. That implies B is equal to C. This is the left cancellation law. Second, A operation C is equal to B operation C. That implies A is equal to B. This is the right cancellation law. For proof, let A belongs to G. That implies A inverse will also belongs to G, because G is the group and inverse of each element must belongs in G, such that A inverse operation A is equal to E is equal to A operation A inverse, where A is the identity element. Now assume A operation B is equal to A operation C. Now we apply A inverse both sides, then this can be written as by the associative law. A inverse operation A operation B is equal to A inverse operation A operation C. A inverse operation A operation B is equal to A inverse operation A operation C. That implies B is equal to C. Now again, for the second C operation C belongs to G, that implies C inverse belongs to G, such that C inverse operation C is equal to E is equal to C operation C inverse, where E is the identity element. Now let us assume A operation C is equal to B operation C. Now applying operation C inverse both sides, then A operation C inverse is equal to B operation C inverse. Now by the associative law, A operation C inverse is equal to B operation C inverse. Now by the inverse law, C operation C inverse can be written as E. So the next line becomes A operation E is equal to B operation E. That implies A is equal to B. This was the first property. This was the first property of the group, that is known as the cancellation law. Right cancellation law and left cancellation law. Now again, we will see the second property of the group. We will prove by the axiom of group. This is the second property. For every A belongs to G has unique inverse in G. Let A is the any element belongs to G and let E is the identity element. Let A inverse and A dash be two inverses of A in G, then A inverse operation A is equal to E is equal to A operation A inverse. That is, A dash operation A is equal to E is equal to A operation A inverse. We have A inverse operation A dash is equal to A inverse operation E. That implies A inverse operation A dash is equal to A inverse. Now again we have A inverse operation A dash is equal to E operation A dash. A inverse operation A dash is equal to A dash. Since A inverse operation A dash is equal to A inverse operation A dash. As in group G is associative, so we can write A inverse is equal to A dash. Hence, every element A belongs to G has unique inverse in G. This was the second property. This was the second property for the group, where by this property, each and every element which belongs in G is has the inverse, and the inverse will also belongs to G. Now we will see the next property of the group. Next property of the group is inverse of an element A belongs to G is itself. That is, A inverse is equal to A. Let A belongs to G, that implies A inverse belongs to G, because A is the element which belongs in group G, and since by the second property A inverse also belongs to G, that implies A inverse is the inverse of A. So we can write that A operation A inverse is equal to A inverse operation A is equal to E. It follows that A inverse to inverse is equal to A. Now we will see the reversible law. A operation B to the whole inverse is equal to B inverse operation A inverse. This is called the reversible law. For the proof, let A inverse operation and B inverse be the inverses of A and B respectively. Since A inverse operation A is equal to E is equal to A operation A inverse, B inverse operation B is equal to E is equal to B operation B inverse. So A operation B inverse operation A inverse, A operation B inverse operation A inverse. Now we say that A operation B inverse operation A inverse is equal to E. Similarly, we again solve B inverse operation A inverse in second bracket with operation A operation B will also E. So we can write this B inverse operation A inverse is equal to A operation E to the whole inverse. This is the property. This was the property of group. Now we will discuss on the abelian group or commutative group. What is the abelian group? By the previous lecture, we have discussed on this topic the 5 properties which are satisfied by the set G, which is non-empty with respect to the binary operation, is called the commutative or abelian group. The first property is commutative property, second property associative property, third property existence of identity, and the fourth property is existence of inverse. This was the properties of the group, and the last property for the abelian group is commutative group. By this property, abelian group is also called the commutative group. By the commutative group property, if A comma B belongs to G are the two elements which belongs to G, then A operation B is equal to B operation A, then this is called the commutative property. Now we will discuss some properties of the group, some properties of the abelian group. This was the definition was the commutative group. Now, so that every element of A belongs to G is itself inverse. So, see the property so that a group G is abelian if and only if AB to the whole square is equal to A square B square for all A comma B belongs to G. Let G is abelian if A comma B belongs to G, then AB to the whole square is equal to AB and AB, that is A in bracket B comma A B. So this can be written as AB to the whole square is equal to A square B square. Now conversely we see that AB to the whole square is equal to A square B square for all values A comma B belongs to G. AB to the whole square is equal to A square B square, that can be written as AB and AB. Now AB to the whole of the square can be written as AB and AB, that implies can be written as AA in first bracket and BB in second bracket. Now in this side we can write this A and BAB is equal to A, AB and BA. Now by using the cancellation law of the group, this can be written as BA is equal to AB, which is the commutative law. Since AB are arbitrary and AB is equal to BA, it follows that G is abelian. This was the property of commutative group. Now the question, what type of questions will be come in the examination? In examination from the group, we can ask, our examiner can ask the question like prove that every elements A belongs to G has the unique inverse G. And the second question can be asked that prove that identity element will also belongs to G. Or next theorem, as a theorem, it can also be proved if A comma B belongs to G and AB to the whole of the square is equal to A square B square, then prove that it is the abelian or commutative group. By these theorems or these results, we can ask the multiple questions, MCQs question like true and false. Suppose we are writing the identity element of A for A with respect to the multiplication operation is 0, this is true or false. Then this will be the false, because multiplication operation always has the identity 1 and the additive identity is 0. Now, suppose question is saying that 1 comma omega square is a group and omega is the has the inverse omega square with respect to the multiplication. This is wrong or right? Then this will be the right. Such type of question will be asked in the examination. Now we will discuss the permutation in the next video lecture.